Hey guys, so I'm going to help you get started on your Igneous Rock Lab today. Notice we've got our box of igneous rocks, 9 of them in here, and this is going to be your data table where you're going to fill in the texture, the cooling rate, and the location of cooling, the magma type, and that together is going to give you the name of your igneous rock and the minerals that are associated with that igneous rock. The first thing we're looking at is texture. Notice rock number 1. Nice, big, easy to see crystals of different colors here. So this has got to be a coarse-grained igneous rock because I can easily see the crystals there. And if it's a coarse-grained igneous rock, that means I had to have this thing cool slowly, intrusively deep within the ground in order to get these large crystals. The next thing we're looking at is the magma type. So we have 3 basic magma types: granitic, andesitic, basaltic. And if you recall from your notes, we said that granitic rocks tend to be pink. Maybe this guy isn't so pink. Andesitics tend to be gray, and our basaltic rocks tend to be very dark colored. So when you look at this, you can see lots of pink colors here. So this guy must be granitic. And if it's granitic and coarse-grained, notice our coarse-grained granitic igneous rocks, we call this granite. This guy's granite. And if you recall from our igneous rock chart, granitic rocks tend to have a lot of quartz, a lot of feldspar in them. So rock number 1 is granite because it's a coarse-grained rock that cooled slowly, intrusively inside the ground. It has a pinkish color, which tells us it's granitic magma type, which means this is the rock granite with lots of quartz and lots of feldspar. Rock number 2. Notice this very dark color, real hard to see any crystals there, just kind of dull looking. Well, that must be a fine-grained igneous rock. So if rock number 2 is fine-grained, it must have cooled fast, which that can only happen extrusively at or near the Earth's surface. So rock number 2 is fine-grained, which tells us it cooled quickly and extrusively. Rock number 2, notice it's very dark, basically a black color there. Which, remember, we said our dark colored igneous rocks are most likely basaltic. And what do we call a fine-grained basaltic igneous rock? There it is, basalt. And our basaltic rocks have lots of pyroxene, maybe some olivine in there. That's that greenish colored mineral. This one, it's kind of hard to see, but it makes it a little bit less dark. So rock number 2, fine-grained because it cooled very quickly, extrusively at the Earth's surface. It's dark-colored, which means it's basaltic, and since we have a fine-grained basaltic rock, it must be basalt loaded up with pyroxene and olivine. In fact, these are the 2 major rocks of Earth's crust. Granite makes up most of the continental crust, basalt makes up most of the oceanic crust. And I'll help you get started just a little bit with rock number 3. Notice, boy, look at that nice shiny texture, but no crystals. So this is going to be our glassy texture. And the other thing I'll point out, remember I said if it's glassy, color is no longer going to help us. This rock is a big fat liar, and even though it's very dark colored, it's not going to be basaltic composition. So be careful as you're doing this. Remember, use your rock ID chart here: granite, diorite, gabbro, rhyolite, andesite, basalt, obsidian, pumice, scoria, coarse grain, fine grain, glassy, to finish out the rest of our 9 rocks.